The first step is to understand the problem. I hope that you've attempted the problem first. You can pause the video at any time and attempt the problem again after you get a hint that you need, but that's the best way to get ahead in physics, is to work the problem as much as you can on your own. So you can start by drawing a picture, looking for some keywords that help you identify what type of problem we're working with, and figuring out what assumptions you have to make the problem easier to solve. So we're at the top of a building, and we're throwing something basically straight up in the air, and it's going to go up and come down, and we're interested in, there's going to be some initial velocity and there's going to be some final velocity. So there's our picture. We're at the top of a building, we're throwing something almost straight up into the air, and it's going to come down, just missing the top of the building and hitting the ground. This is a projectile motion problem. So if there's no air drag, then we can say the acceleration is constant. So let's just state, we're going to assume no air drag, and at this stage in our physics problem solving capability, we also have to assume that this is a point object. Because if objects can have dimension, they can rotate, we don't have the tools to deal with that yet. We will in about 8 weeks. So the next step is to set up the problem. We need to define our origin and our positive directions. You can pick any place you want to be the origin. It can be the bottom of the building. It can be the top of the building. It can be anywhere in between. It can be the highest point the projectile reaches. It can be any other point. But there are 2 points that make the most sense. The top of the building, where you're throwing the object, and the bottom of the building where it lands. I'm going to pick my origin to be the top of the building. And our positive direction, do we want it to be up or down? It doesn't really matter. Most students like up to be positive, so why don't we go with that? So at this point here, we have y equals 0, and any point above that is our positive direction. And you have to remember that the axis is a number line. So if as we move up we have positive 1 meter, positive 2 meters, positive 3 meters, when you move down you're going to have negative 1 meter, negative 2 meters, negative 3 meters. It's a number line. Don't get hung up on having a negative distance. It's not a distance, it's a location on a number line. Okay, now you need to understand what data you have and what you're trying to solve for. And when you're working projectile motion problems, it's best to start off with a little table. And the 5 things you need to know, y initial and y final, that's really one thing. That's your change in your y direction. V initial, V final, acceleration, and time. So you've got 4 parameters and a change in y. So 5 things you need to know to solve a projectile motion problem. The nice thing is, if you know any 3 of them, you can solve for the other 2. So what's our y initial? Well, we're starting out at the top of the building. We said that was our origin. So we're starting out at 0. Our y final is down here. And it's given in the problem that's 50 meters below our starting point. So that's 50 meters in the negative direction from our origin. So negative 50 meters. V initial is what we're solving for. V final, we don't know that either. We could solve for it. The acceleration is the acceleration due to gravity, 9.8 meters per second squared. And in what direction is that acceleration? It's down, which is our negative direction, negative 9.8. And in the problem it's given, we're looking for V initial at 5 seconds. T equals 5 seconds after the projectile is launched. So to find V initial, we're going to look at our kinematics equations, and we'll pick the one that's missing, the equation that's missing the information that we're missing. So we're missing V final. So we'll pick an equation that's missing V final. How about this equation? Y final equals Y initial plus V initial t plus 1/2 a t squared. So we have all the information except for V initial, and we can plug everything in and solve and have V initial. So I've got minus 50, 0 for Y initial, I think I plugged everything in correctly. Remember, when you plug in these numbers, you always retain the negative signs with them. So we've got a negative 9.8 for our acceleration, negative 50 for y final. And if you take a quick look at this, you'll see that time is seconds. So we have seconds squared. Acceleration is meters per second squared. So the seconds cancel and you're left with meters. And the same is true with the middle term, and every term has the same units. So what do I end up with here? Minus 50 is 5 V initial minus 122.5, and I have V initial is a positive. I'm going to write the positive sign here just so I don't forget. Positive 14.5 meters per second. And let's take a look at our drawing. V initial was up in our positive direction, so we expected the answer to be positive. And it is. And the magnitude is 14.5. The units are meters per second. And that's a good thing to do when you get an answer. Go back and think about the problem for a minute. Did you get the right sign? Did you get the right units? Does the magnitude make sense? In this case, it's hard to know if the magnitude makes sense, but we can tell that the units and the sign are correct. Just for fun, why don't we go ahead and solve for V final? So I'm going to pick an equation I can use. How about this one? V final is V initial plus AT. My initial velocity is 14.5 positive. My acceleration is negative 9.8, and my time is 5 seconds. And I get negative 34.5 meters per second for my final velocity. And if we go back and take a look at our picture, our final velocity is pointing in the negative direction. So we expected that to be negative. The units are meters per second, and the magnitude is 34.5.